So in the last chapter, we also see the byte pair encoding. So in this video, right, we will explain the BP in more detail. So let's have a quick recap, right, for the tokenizations used in the sentence piece. So basically, sentence piece is an unsupervised text tokenizer and the tokenizer developed by the Google, which is actually widely used in the NLP, right, such as text-to-text transformer model and the MT5 model or the Google multilingual word. So here it actually takes the text as a raw stream of character which performs the subword level tokenization without depending on the pre-segmentation. So as we discussed that sentence piece already consists of the two algorithms. One is the byte pair encoding and the Unigram language model. So in this lecture we'll only focus on the byte pair encoding algorithm. So to understand the byte pair encoding, let's consider the following words, right? Hugging face, hugging, similarity learn, and we put these words into a corpus in rows like this, and we count the frequencies of each words given, right? For example, hugging face is one time, hugging is one time. So similarly, learning is two times, learner is two times. Okay, here learn is one time. Okay, so once the frequency is defined, we actually split the each words into a character wise. So for hugging face, it is like HUGGING FAC. So like that, we have to split all the words into a character wise. Fine, clear? So next part is that, so once the character split is done, right, we have to find the pairwise frequency. So as I mentioned, right, byte pair encoding generally like does the pairwise frequency, to provide a kind of a big corpus, right? So finally, in this pairwise, if you see, right, how many times HU is used, right? 1, 2, 3, 4. So like that, UG, how many times? So UG 1, 2, 3, 4, correct? So similarly GG 1, 2, 3, correct? So then GI 2 times. So like that, we all define all the pairwise frequency here. Clear? Now, next part is that let's assume, right, I define a kind of a byte pair token bucket. So you'll see, right, we'll put all these pairs, right, out of this pair frequency and put into the bucket, and finally we pass to a vocabulary list dictionary. So this is the final output of the dictionary, which actually form the final tokens out of the corpus given by the different words as a input. Okay. Now, in this case, let's from the bucket, I'll put all the red mark arrow, right, and try to put or kind of segregate into different tokens in this vocabulary list. Now, in this paired frequency number, if you see which pair has the maximum value, right? So that is the LE, correct? So this one, LE, 1, 2, 3, 4, correct? So step number 1, LE has the max. So I'll put this LE in this corpus. So here, please note that the initial corpus is already the words given from this list of the words, right? So in terms of each character. So we'll already define. Now the pairwise I have to provide here, correct? So here, as I mentioned, LE has the maximum. So I'll put this here. Fine. So if you see, LE is already done. Next, what is the maximum pair here? EA, right? So we'll find EA. So EA, right? So this is also a pair 1, 2, 3, 4, right? And obviously it is the 2 times, so that's why it's total 7. So again we'll sort it out from this LE, which is actually the maximum, and put in the vocabulary dictionary list. Correct? So this is done. These 2 pairs. Next. So we are actually increasing the corpus here. Next, what is the maximum, right? If you see here, LEAR, correct? So this is 2 times 4, 6 and 7. So this is LEAR is the maximum part, right? So from there, AR is also there, correct? AR is already or taken care from here, right? So it is already within this LEAR. So we can also cross it or sort it from there and put the in the dictionary list. Clear? Next, we'll go to here. Next part is that what is the maximum size? LEARN. So this is the final token, right? LEARN, which has the maximum, right? So within this RN, right? So it's already taken care because it's already 7, correct? So if you see, right, so this is a kind of a 7, right? So twice we can see 6th and 7th. So we'll put in the dictionary here, correct? So this we can also sort it from here. So similarly, ER, right? So if you see, right, ER. So ER has the maximum out of this, which is actually 5. Okay. So this I can sort it out here from here. ER. So twice. Okay. And this one is a single one. So this I can also sort it out and put in the dictionary corpus. Fine. Next, again, if you see HU has the maximum, next max, right, which is actually 4, right? So similarly, the same process I can put it here. Okay. So then again, HUG. So where is HUG? So it is taking, right? So HU is already taken care. So HUG is the next token we find, right? And put in the next corpus. So if you see, these all are already sorted out. So it's not required no more because these all sorted and put it in the kind of a margin and finally put in the dictionary, right? Okay. Next, similarly in, right? I am kind of a IN. I am sorting this in, right? So I am actually removing like that, and putting in the dictionary. So similarly here, for this case also, right? FA, the similar case, right? We actually put in this corpus. So FA needs to be removed from here, correct? And finally, if you see like that, we actually remove FA CA, correct, margin, and finally put in the dictionary corpus. Similarly here, write FAC, correct? So this is twice taken in this corpus and put it here. So similarly face, so is a final token here. Okay, within this face you can check, right? FA, AC already taken care. Okay, and we put it here in the final dictionary. And like that GE, right? G. So it is the next one. So it's 1, right? So you can put in the final dictionary vocabulary list. So similarly G we can also put right in the list. And if you see as a final output, correct? So this is the final vocabulary tokens which I am actually getting from this words, or kind of a list of words while implementing the byte pair encoding. So finally the output looks like that. So let's summarize what is it. So as I mentioned in the one of the previous lecture, right? So these are by default, right? Already mentioned with respect to the token ID, right? So unknown is taken as a token ID. 0 by default is where the start of the sentence, right? Like this is a end of the sentence. Then underscore represent the space, right? These are already taken care of, as I mentioned. So HUGING. So if you see right here the corpus, so this is the token ID. What I am putting here is a token ID 4.5. So this is token ID 4, token ID 5, like that. So in summary, what is the intuition? There are certain token IDs by default, like unknown, underscore, start of word or end of word, and after that whatever the corpus is formed, irrespective of the frequencies of the byte pair, right? It takes a token ID out of that, like your token ID, right? 4, 5, 6, 7, like that. Like for example, it may be like 10, 11, like that. It form. So the entire summary is provided here, like irrespective of the corpus is like whatever I shown, right? So finally, this form a kind of a total 30 tokens has been formed from there. So these are the final byte pair subword tokens stored in the model vocabulary, which is as a unique ID generated inside the model file. Clear? And finally, if you see, like let's say I search for input, like in the vocabulary hugs. So in the vocabulary search, it actually searches the from the initial vocabulary list of dictionary. So it is actually searching HUG. Okay, it's taking, right. So there is another S. So finally there is already the tokens hug is there. So from the vocabulary search, we get final output as a 2 tokens. One is hug and one other is S. Okay. So that's all for these video lectures. I believe everyone has a clear understanding how byte pair encoding works. Thank you very much for watching this video. Please subscribe this video as well. Thank you. Have a nice day.